This is an audio-visual presentation on decimal fractions. Now let's consider some examples of a decimal fraction. We have 23.42, 47.38, and 79.23. Now, when we consider the example in I, 23.42, we have two digits after the decimal point. So the digit after the decimal point determines the number of places of the decimal fraction. So because we have two digits after the decimal point in example 1, it means that 23.42 is in two decimal places. Now considering the example in II, 47.38. Here, because we also have two digits after the decimal point, it implies that 47.38 is in two decimal places. Now, with 79.23, we also have two digits after the decimal point, and therefore 79.23 is also in two decimal places. Take note that the numbers before the decimal point are the whole numbers. So from 23.42, the whole number is 23. With 47.38, the whole number is 47. And from 79.23, the whole number is 79. These are all examples of a decimal fractions. These are all examples of a decimal fraction. Now we have changing decimal fractions to common fraction. Now we are going to look at how we can change decimal fraction to common fraction. Now take note of this. Assuming you are given this decimal fraction, A.BCD. A is the digit before the decimal point. B is the first digit after the decimal point. C is the second digit after the decimal point. And D is the third digit after the decimal point. Now, A, that is the number before the decimal point, is the whole number. The first digit after the decimal point is the tenth. The second digit after the decimal point is the hundredths. And the third digit after the decimal point is the thousands, in that order. Now let's continue. Example 0.7. When we consider 0.7, the first digit we have after the decimal point is 7, and 7 is occupying the 10th position. So 0.7 is equal to 7 tenths, and 7 tenths is equal to 7 divided by 10. So in that case, we have converted 0.7 as a decimal fraction to 7 over 10. To 7 over 10. Now, let's consider this example. 0.07 is equal to, now we can see that the 7 has occupied the 100th position because it's the second digit after the decimal point. And that is equal to 7 hundredths. And 7 hundredths is equal to 7 divided by 100. And so 0.07 as a decimal fraction is equal to 7 divided by 100. Is equal to 7 divided by 100. Now 0.31. 0.31. So we have two digits after the decimal point. That means that 0.31. 31 is occupying the first two digits after the decimal point. That's the 10th position and the 100th position. So in all, we say 0.31 is equal to 31 hundredths. And that is equal to 31 over 100. Now considering 0.073. 0.073. This is equal to 73 thousandths, because 73 is occupying the thousandth position, because we have three digits after a decimal point. 0.073 equals 73 thousandths, and that is equal to 73 divided by 1000. 73 divided by 1000. Now, if you look at the trend, if you look at 0.31, you can see that it's equal to 31. That is the number divided by 100, because you have two decimal places. That is why you have two zeros. and the 1 is constant. So 0.31 is equal to 31 over 100, where the number of decimal places determines the number of zeros. Now with 0.073, that is equal to 73 thousandths. It's equal to the number, and the number itself is 73, divided by, let the 1 be constant, because 0.073 is in 3 decimal places. That determines the number of zeros, and that is how come we have 1, 2, 3 zeros. So in all, 0.073 is equal to 73 divided by 1000. Now let's look at the method 2 in converting decimal fractions to fractions. Now 0.13, when we consider 0.13, the first digit after the decimal point is 1, and that 1 is occupying the 10th position, and so 0.13 is equal to 1/10 plus 0.13. When we look at the number 3, it's occupying the 100th position, because the number 3 is the second digit after the decimal point, so it is occupying the 100th position. Now 0.13, because the 1 is occupying the 10th position, it is 1/10 plus, because the number 3 is occupying the 100th position, is equal to 300. Now 1/10 will be equal to 1 divided by 10 plus 300 is equal to 3 divided by 100. Now let's simplify. The LCM of 10 and 100 is 100. So 10 goes into 100 10 times. Then we multiply 10 by the numerator, 1, and the answer is 10. Plus 100 goes into 100 once. When we multiply the 1 by 3, we have 3. So this is equal to 10 plus 3 divided by 100. And the answer is 13 divided by 100. That means that 0.13 is equal to 13 divided by 100. Now example, from 0.31, we can see that we have 2 digits after the decimal point. Now 3 is occupying the first position. The first digit is 3, and 3 is occupying the 10th position. 3 is occupying the 10th position. So 0.31 will be equal to 3/10 plus 1 is occupying the 100th position. That's the second digit after the decimal point, is the 100th position. So because 1 is occupying the 100th position, this will be equal to 100. And so 0.31 is equal to 3/10 plus 100. Now 3/10 is equal to 3 divided by 10 plus 100 is equal to 1 divided by 100. Now we find the LCM of 10 and 100. 10 goes into 100 10 times, and 10 times 3 is equal to 30, plus 100 goes into 100 once, and 1 times 1 is equal to 1. So we have 31 plus, that is 30 plus 1, which is equal to 31, divided by 100. So this is equal to 31 divided by 100. This means that 0.31 is equal to 31 divided by 100. Is equal to 31 divided by 100. Now when we consider the decimal fraction 0.073, this is equal to 0/10. That is, the 0 is occupying the 10th position, 7 is occupying the 100th position, and 3 is occupying the 1000th position. So 0.073 will be equal to 0/10 plus 700 plus 3000. So 0.073 is equal to 0 divided by 10, because 0 is occupying the 10th position, plus 7 divided by 100, because 7 is occupying the 100th position, plus 3 divided by 1000, because 3 is occupying the 1000th position. Now we find the LCM, and the LCM of 10, 100 and 1000 is equal to 1000. 10 goes into 1000 100 times, and 100 times 0 is equal to 0, plus 100 goes into 1000 10 times. 10 times 7 is equal to 70, plus 1000 goes into 1000 once, and 1 times 3 is equal to 3. Now 0 plus 70 plus 3 is equal to 73, and so we have 73 divided by 1000. This means that 0.073 is equal to 73 divided by 1000. Now, considering 5.27, the digit before the decimal point is 5, and that is the whole number. So considering 5.27, this is equal to 5, that's the whole number, plus, because 2 is occupying the 10th position, it is plus 2/10, plus 7 is also occupying the 100th position, so it's plus 700. Now the whole number is 5, so we have 5 plus, because 2 is occupying the 10th position, is plus 2/10, then plus 700. That is because 7 is occupying the 100th position, is 7/100. Now we find the LCM of 10 and 100, and it is 100. 10 goes into 100 10 times, and 10 times the numerator 2 equals 20. Plus 100 goes into 100 once, and 1 times the numerator 7 will give you 7. Now 20 plus 7 is equal to 27. So we have 5 plus 27 divided by 100. That is why we have 5 plus 27/100. Now when we simplify 5 plus 27/100, we have 5 whole number, 27 divided by 100. This is a mixed fraction. So let's convert this to improper fraction. Now how do you convert this? 100 times 5 equals 500. And 500 plus 27 equals 527. Divided by the denominator of the fraction, that is 100. So this is equal to 527 divided by 100. The above examples are terminating decimals. They all have a finite number of decimal places. Now let's look at recurring or recurrent decimal fraction. Recurrent decimals are repeated decimals. These are decimals that repeat themselves. Now let's look at what I mean by that. 5 divided by 8 is equal to 0.555555. So you can see that the 5 repeats itself so many times. So 5 divided by 8, which is equal to 0.555555, can be written as 0.5 with a dot on top of the 5. Why? This means that 5 repeats itself. Now 2 divided by 11 is equal to 0.181818, or it can be written as 0.18 with the 2 dots on top of the 1 and the 8. Why? Because it is the 1/8 that repeats itself so many times after the decimal point. Now 8 divided by 15 is equal to 0.53333. So we can see that it is the 3 that repeats itself, and so this can be written as 0.53 with the dots on top of the 3, meaning that it is the 3 that recur. It is the 3 that recur. Now changing recurring decimals to common fractions. How do we change recurring decimals to common fractions? Now example, write the following rational numbers in the form a over b, where a and b are integers and b is not equal to 0. That is, the denominator is not equal to 0. A 3.222222, then b 0.431431. So let's look at how best we can solve this problem. Solution: let r be equal to 3.222222. This is the question we are given. So let r be equal to that decimal fraction. Let this be equation 1. Let this be equation 1. Now we multiply the left by 10, and so we have 10r, and this is equal to 32.222222, because we have also multiplied the right by 10. Now we can see the recurrence of the decimal, that is 22. We are now subtracting equation 1 from equation 2. When we subtract equation 1 from equation 2, we have to subtract r from 10r on the left hand side. So when we subtract r from 10r on the left hand side, the answer is 9r, and this is equal to, when we subtract 3.222222 from 32.222222, the answer is 29. Now if 9r is equal to 29 and we are solving for r, we have to divide both sides by 9. So dividing 9r by 9, we are left with r. And when we divide the right hand side by 9, that is 29 divided by 9. So r is equal to 29 divided by 9. R is equal to 29 divided by 9. And this is equal to 3 whole number 2 over 9 in mixed fraction. Therefore, 3.222222 is equal to 3 whole number 2 over 9. Is equal to 3 whole number 2 over 9. So that is how we convert recurring decimals to fractions. Now B. Let R be equal to 0.431431. Let this be equation 1. So we multiply the left hand side by 1000. In doing that, we have 1000 R. And this will be equal to 431.431431. That's equation 2. Now, when you multiply, look at this before you continue from here. Now, when we multiply the left hand side R by 10, we have 10R. And when we multiply the right hand side by 10, we have 4.31421. The recurring pattern has changed. That is why we did not consider multiplication by 10. When you multiply R by 100, you have 10R on the left hand side. But when you multiply the right hand side by 100, you have 43.1421. The recurring pattern has also changed. But when you multiply R by 1000, you have 1000 R on the left hand side. And on the right hand side, you have 431.431. So the recurring is also seen when we multiply through by 1000. And that's the reason why we multiply the R by 1000. And this is equal to 431.431431. And that's equation 2. So we now subtract equation 1 from equation 2. So we take R from 1000R. And that will give us 1000R minus R. This is equal to, we subtract 0.431431 from 431.431431. And the answer is 431. So we have 999R on the left hand side is equal to 431. And so if you want to make R the subject, you have to divide the left hand side by 999. And you have to divide the right hand side also by 999. This implies that R is equal to 431 divided by 999. And therefore 0.431431 is equal to 431 divided by 999. Now take this as an exercise. Write 0.16666666 in the form A over B, where A and B are integers and B is not equal to 0. Now, after solving for the problem, the answer will give you 1 over 6. You will get 1 over 6 as the answer. You will get 1 over 6 as the answer. That is your exercise. Now let's look at addition and subtraction of decimal fractions. Addition and subtraction of decimal fractions. Now, considering this example A, we have 2.6 plus 3.84 plus 12.96. B, we have 12.8 minus 6.79. Now let's look at how we can solve these two problems. A, we were given 2.6, B, 3.84, C, 12.96. Now the arrangement is done as shown. The decimal point is vertically in line as shown. Please, the decimal point should be vertically in line. So we have 2.6 plus 3.84 plus 12.96. Now let's begin to add. So 4 plus 6. 4 plus 6 will give us 10. So we write 0. The remainder is 1. 1 plus this 6 will give us 7. And 7 plus 8 is 15. Now 15 plus 9 is 24. So we write 4. And the remainder is 2. So 2 plus 2 is 4. 4 plus 3 is 7. And 7 plus 2 is 9. And we have our 1 here. So 2.6 plus 3.84 plus 12.96 is equal to 19.40 is equal to 19.40. Now let's look at the solution in B. 12.80 minus 6.74. So we subtract 4 from 0. And because 4 is greater than 0, we have to borrow 1 from 8. When we add the 1 to 0, we have 10. Now when we subtract 4 from 10, the result is 6. Take note that you borrowed 1 from here, and so we are left with 7. Now 7 minus 7 will give us 0. Don't forget your decimal points. Now before the decimal point 12, you have 12 here, and that's the whole number. And before the decimal point here, you also have 6, and that's the whole number. So when we subtract the 6 from 12, the answer is 6. Or when you subtract 6 from 2, because 6 is greater than 2, you borrow 1 from here, add it to 2, and that will give you 12, because the one you are borrowing is 10. So 10 plus 2 will give you 12. So still, when you subtract 6 from 12, you are still getting 6. And because you borrowed the 1, there is nothing there again. That means that 12.80 minus 6.74 is equal to 6.06. Is equal to 6.06. Now multiplication of decimal fractions. Evaluate. 2.91 times 1.2. B. 1.45 times 2.8. C. 0.1 times 0.2 times 0.3 times 0.4. Now let's look at how we can solve this problem. Multiplication of decimal fractions. Now with the example we are given, let's consider the first example. A. 2.91 times 1.2. Now when you are given decimals to multiply, take note of this. Your concentration should be the decimal places. Now with 2.91 we have 2 decimal places, and with 1.2 we have 1 decimal place. So in all you are going to have 3 decimal places. Now when you are given 2.91 times 1.2 to multiply, because they are decimals, what you do is don't consider, assume that the decimal point is not there. So 2.91 becomes 291, that is 291, times 1.2, assuming the decimal point is also not here, we have 12. So 291 times 12 will give us 3,492. Now after multiplying the whole numbers, that is 291 and 12 to get 3,492, you will have to now count the decimal places. And the decimal place here is 2. The decimal place here is 1. So together we have 3 decimal places. That means that 3.492 is equal to 3.492. That is 3,492 will be equal to 3.492 to 3 decimal places. To 3 decimal places. 3 decimal places because the total decimal places of the 2 decimals multiplying is 3. And therefore 3,492 is equal to 3.492 in 3 decimal places. Now 1.45 times 2.8. So you still assume here that you don't have any decimal point. So 1.45 becomes 145 times 2.8 also becomes 28. Now when we multiply 145 by 28, the answer is 4060. That is 4060. 4060. Now with the first decimal fraction 1.45, we have 2 decimal places. And with the second decimal fraction, we have 2.8. That's 1 decimal place. So 2 decimal places together with 1 decimal place will give us 3 decimal places. That means that 4060 is equal to 4.060. Is equal to 4.060 to 3 decimal places. Now C. 0.1 times 0.2 times 0.3 times 0.4. So you now ignore the decimal point and multiply the numbers. So we have 1 times 2 times 3 times 4, and 1 times 2 times 3 times 4 is equal to 24. Now take note, we have 1 decimal place here, 1 decimal place here giving us 2, 1 decimal place here giving us 3, 1 decimal place here giving us 4. So we have 4 decimal places in all. That means that If 1 times 2 times 3 times 4 is equal to 24, then into 4 decimal places it will be 0.0024, so that we can have 4 decimal places, because the number of digits after the decimal point is the number of decimal places. Now division of decimal fraction. Example, 0.48 divided by 0.2. This is equal to 0.48 divided by 0.2. Now it is easy when you are dividing a decimal fraction by a whole number. So let us do something. What we are going to do is to multiply the numerator by 10, and we also multiply the denominator by 10. Multiplying the numerator 0.48 by 10, we have 0.48 times 10 divided by, when we multiply 0.2 by 10, we have 0.2 times 10. Now 0.48 times 10 is equal to 4.8, and 0.2 times 10 is equal to 2. Now our denominator is now a whole number, so 4.8 divided by 2 will be equal to 2.4. That is 2 goes into 4 twice, and 2 goes into 8 4 times. So 4.8 divided by 2 is equal to 2.4. This is the end of our presentation on decimal fractions.